Introduction to Big Data and Hadoop. So guys, let's start with the agenda. Guys, we will start with the introduction to big data. We'll discuss several aspects of big data. Then we'll talk about 7 V's of big data. These are different dimensions of big data, conventional approaches and problems associated with it. Then guys, we'll discuss the technology that handles big data, that is Hadoop. Core components of Hadoop, that is HDFS and MapReduce. Then guys, we'll talk about Hadoop ecosystem. Hadoop is having tons of component in its family. That's Hadoop ecosystem. Then guys, we'll talk about real life use cases and future and careers in big data. Let's start this session with what is big data. What is big data? Guys, the wave everyone is riding. Nearly all big players, all Fortune 500 companies, and many smaller ones are onboarded. Everybody is running behind big data. Big data is the biggest buzzword of the industry. Let's see what leaders say about big data. Guys, what IBM says, big data is a business strategy for capitalizing on information resources. Very big statement from IBM. Gartner. Guys, we are aware that oil is the most valuable thing on the planet, and according to Gartner, big data is the new oil. Very big statement. According to IDC, big data market will be growing 7 times faster than overall IT market. 7 times faster than overall IT market. That's really huge. Another very big statement from IBM. Big data is not just a technology. It's a paradigm shift. Guys, we are aware that in late 80s, we shifted to RDBMS. From older technologies, guys, we shifted to RDBMS. RDBMS, a nice technology which served us for more than 2 decades. It's pretty much matured, pretty much nice, but RDBMS quite old to handle our new requirements. It can't handle our new requirements. Guys, that's why we have a paradigm shift. We are shifting from older technologies, that is your conventional legacy systems, to big data. Let's proceed ahead. Now, guys, let's talk about what happens in a minute. Little facts and figures. 4 million search queries are submitted on the Google just in a minute. Let me highlight the figures. 300,000 tweets just in a minute. Really huge. 2.5 million pieces of contents are shared on the Facebook. 72 hours of new videos are uploaded on YouTube just in a minute. 50,000 apps are downloaded by Apple users. 220,000 new photos are uploaded on Instagram. Guys, just in a minute, $80,000 online sales generated by Amazon. 200 million emails are sent just in a minute. Guys, there is a reason why I have shown you these statistics. Corresponding to these events, 4 million queries, 200 million mails, 80,000 USD sales, 2.5 million pieces of contents. Guys, corresponding to these events, huge volumes of data is generated. Huge volumes of data in the range of hundreds, thousands of TBs, even in the range of petabytes are generated. That too with very high speed. You can see, guys, the speed. Just in a minute, 4 million search queries, 200 million emails. So guys, we are generating actually big data. If we talk about a very simple, very basic definition of big data, what exactly is big data? How big data looks like? Guys, big data is the data that exceeds the processing capacity of conventional databases. If I add one more line, it exceeds the processing as well as storage capacity of conventional database. Guys, the data is too big. Moves too fast and doesn't fit in the structure of your RDBMS. Guys, the volumes are very big, speed is much too fast, and structure is random, that's unstructured. Guys, that's why this data doesn't fit in the structures of RDBMS. We need an innovative form of solution. That can handle these data sets. Let's proceed ahead. Another definition. According to IBM, guys, by the way, very big statement, 80% of the data captured today is unstructured. Really very big statement. Why? Because, guys, till now we didn't have any mechanism to handle unstructured data. So what we were doing with this 80% of data? Simply dumping off. We were not capable to handle these unstructured data sets. Now, guys, you'll ask me, suddenly, earlier we were not able to process these data sets. Earlier we really wasn't able to generate the insights. Suddenly, what happened in the industry that we need these data? We want to process this data. Guys, industry is running behind big data. Why? Because industry want to generate the insights from the big data. Guys, if I give you one example, like earlier, how our sales reports were look like? It was a historical analysis. Sales reports, like insights reports analysis, was merely historical. What happened yesterday? What happened last month, last week, last year, last festive season, and so on. What was my sales what was my sales last specific period of time at a specific store or in a specific region. Similarly, something like just few different combinations of historical trends were generated. But guys, today requirements has changed. Today industry want to know what will happen. That is predictive analysis. That is predict the future. What will happen? Like guys, in next few months, suppose there is a festive season. What will be my sales pattern in next few months? Say for example, next 4 months. I wanted to know what will happen. Say for the out of say suppose I am a retailer. I am having millions of products. Which product sales will be high, which product sales will be low, in which region the sales will be high. Accordingly, I can make PO. So guys, this is called predictive analysis. We can predict. By the way, this is a really very big gift from big data to the industry, that we can predict. This is the real application, that what will happen based on the past transactions. Suppose we are having past 10 years of transaction records. Based on that, we can predict what will happen in near future. That's really huge. That's really a very big success. If being the retail owner, if I come to know that this will happen in next 6 months, I can make all the required arrangements. So guys, if I summarize this particular discussion, industry is interested in processing the big data to generate the insights. That too in actionable form. That is, out of your reports, if I can take any decision. Alright, we'll discuss several use cases in use case section. Let's proceed ahead. So guys, we were discussing about IBM's definition of big data. IBM says 80% of data captured today is unstructured. These data sets are generated from sensors used to gather the climate information, post to social media, digital pictures, videos, purchase transaction records, cell phone GPS signals, and so on. All these unstructured data is also big data. Let's proceed ahead. Guys, let's talk about few characteristics, few statistics. Every day we create 2.5 quintillion bytes of data. 2.5 quintillion bytes. That is 2.3 trillion GBs. Just in one day. So much that 90% of the data in the world was created in just last 2 years. Guys, from the day of its inception, from the day of the inception of data till 2013, whatever volume was created is merely contributing 10% of the data available on the planet. And from 2013 to 2015, the data generated during this particular duration is contributing 90%. That's really huge. Guys, the data generation curve is pretty much exponential. It's pretty much exponential with time. So guys, earlier in 90s, late 90s, it was expected that data generation curve would be linear with time. So it was expected that we will be having somewhat this much volume of data at this time. But guys, we reached to this new height. There is a huge gap between our ability to do something with the data and actual volumes available. So guys, we need an innovative form of solution. We need an innovative form of solution to handle these data set. Let's proceed ahead. Guys, how big data is different? Let's talk about it. What exactly is the difference with traditional data sets? Like earlier also we were collecting the data. Like transaction data. We were collecting data from CRM. Traditional sources of data. But now, if we talk about first source, automatically generated by sensors. Guys, we are increasingly surrounded by sensors that collect and share the data. Even if we take the example of our smartphones, it contains GPS to track exactly where are you at any point of time. It includes accelerometer to track the speed and direction at which you are traveling. It generates huge volumes of data. Huge volumes of data generated by social media. Guys, with the introduction of social media, huge volumes are generated. We already discussed in earlier section, like 2.3 million pieces of content shared on Facebook just in a minute. You can imagine, guys, the volume that is generated by these social media, Facebook, Twitter, and tons of, like, if we include few extra like user review websites, blogs, news sites, and so on. So guys, these social media data is also pretty important for the industry. How? Let me give you just one example. It helps the industry in knowing about 360-degree view of customer. It means each and every detail of the customer, what customer like and what he doesn't like. If we take one more example, generated by Internet of Things. Guys, we now have smart TVs. Smart watches, smart fridges, smart alarms that are able to collect and process the data. The Internet of Things connects all these devices. So guys, if we take one example, like the traffic sensor on the road sends data to your alarm clock, which will wake you up earlier than the planned time because of blocked road. Means you have to leave earlier for your meeting. Your traffic sensor is sending information, is sending the data to your alarm sensor, alarm clock. So say for example, earlier you were planning to leave at 9 a.m. Now you might need to leave 15 minutes early due to traffic. Apart from that, guys, like if we take one more example that is pretty much popular, stream of data, continuous stream of data. As soon as, guys, say for example, if we visit a website, let's talk about any e-commerce site. E-commerce owner will able to identify us. Like say for example, if I give you guys very small example, if we are searching for a butter, if we are searching for a butter, if e-commerce owner can give within a 10 seconds, 20 seconds at max, 20 seconds is frankly speaking too much. Within 10 seconds, if he can give me advertisement corresponding to butter, that currently I am looking for, say, Britannia butter, and e-commerce will give me an advertisement that go for Amul butter, there is a 10% discount. You are currently looking for, say, HTC mobile phone, it will tell that quite similar aspects, quite even better specs are there in Motorola phone. Or if I have purchased, say for example, a Motorola phone, immediately it should give the advertisements of accessories. Guys, this data that is generated is actually collected in continuously stream form, and that too processed in real time to provide the results, to provide the like advertisements or response in real time, that too in the range of 5 seconds, it makes 10 seconds. As soon as you open a website, say for example you open Amazon, immediately Amazon will give you recommendations in just few seconds. You might like this, you might like that, in different sections. In electronic section you might like this, in apparel section you might like this, in book section you might like this. How? Amazon will collect the data from your browser, all your cookies, and based on that it will give you a recommendation very fastly. A very, very nice example. Let's proceed ahead. Now guys, if we talk about 3 important V's of big data, although as I told you initially there are 7 V's, out of which these 3 are quite important, like volume, velocity and variety. All of these if we include all of these, it will increase the complexity of data, increase the complexity of big data. These 3 are the we can say essence of big data. Let's start with the volume. Guys, volume, massive volume of data is getting generated, that is in the range of terabytes to zettabytes. By 2020, guys, the size of digital universe would be 40 zettabytes. 40 zettabytes, that's huge. Most of the companies in US have more than 100 TBs of data. Guys, as discussed earlier, every day we generate 2.5 quintillion bytes or 2.3 trillion GB of data. Volume is pretty simple dimension. We understand quite easily that size of data. Size is quite huge. Let's proceed ahead to next dimension, that is velocity. Guys, velocity, we already discussed a small definition, that is speed of data generation. Let's talk about another definition from a leader, Gartner. Velocity means both how fast the data is being produced and how fast the data must be processed to meet the demand. Guys, we must be able to process the data at the speed of generation. at the speed of generation. Like if I give you one example, New York Stock Exchange captures 1 TB of trade information during each trading session. 1 TB. And guys, you can imagine there will be millions or even in the range of billions of records. All these transactions must be analyzed against fraud. You can imagine, guys, the speed at which we need to process the data. If we take another example, guys, Google alone processes over 3.5 billion search queries in a single day. That's really huge. So guys, velocity refers to generation speed as well as processing speed, and today industry is more interested in knowing the results in real time. What is happening at all my stores at this point of time, how my network is performing. A network operator is pretty much interested in knowing about it. Say for example, at 3 a.m. a specific portion, in a specific region, there is an issue in my network. Guys, if you take 5 hours in detecting the issue, that there is an issue at this point, just to detect where exactly if there is any issue, then it would be a worst case, because 5 hours my network is down during that time and customers are facing difficulties in connecting the calls. Today, immediately within few seconds, alarms must be raised as soon as my network link is down. As soon as there is any issue in my network, immediately alarms will be raised and management will come to know there is an issue and required action will take place. We'll talk one more use case about the velocity, that is credit card fraud detection in use case action. Let's proceed ahead. Variety. Guys, another dimension of big data, variety, different forms of data. Guys, earlier we have I can say a theoretical solution to store the data, that was RDBMS. Why I'm saying theoretical solution? Because it was able to handle just structured data, and we are having data that is in the tons of varieties of format. Google generating data in different format, Yahoo different, Facebook different, Twitter different, and even if we come to the industry, Walmart retailer different, AT&T telecom different, healthcare different, finance different. Everybody is generating the data in different form. So guys, variety refers to different forms of data. So guys, if we discuss few cases, 30 billion pieces of contents are shared on Facebook every month. Totally different form. 4 billion hours of videos are watched on YouTube every month. Again, totally different form. 400 million tweets are sent per day by 200 million active users. As of 2011, guys, the size of healthcare data was estimated to be 150 exabytes. 150 exabytes. That's really huge. So guys, these are the most important 3 V's of big data. We have other 4 V's like veracity. Veracity refers to uncertainty in the data. Volatility refers to how long data is valid. Validity, that is related to volatility. Correct data, use for your analysis, use the valid data. And last V, seventh V is the value that you can extract from your data, that you can extract from big data. We'll talk about remaining 4 V's in subsequent sessions. Let's proceed ahead. Guys, let's talk about problems associated with the conventional approaches, your legacy systems. Guys, the very first problem, limited storage capacity. I'm sure guys, all of you who are using the legacy systems are facing limited storage capacity issue. Let's take one example. Oracle, most popular data warehouse, can be deployed on merely one machine. You can't store the data beyond certain limits. Guys, if I take one example, when I visited a leading telecom operator, they were able to store only pretty limited volume of data. What about the data older than a specific period? Like they were able to only handle 6 months of their live data. Data older than 6 months, they need to archive. Guys, important point. According to data scientist, archival means data death. Archival means data death. In today's industry, nobody really can suggest or accept archival of data, because that is of no use for you. Archival means data death. Let's proceed ahead. Limited processing capacity. Since your systems, your technology deployed on single machine, you have limited CPU cores. You can process the data at limited speed. In the use case section, guys, I'm having a very nice use case where we reduced processing time from 10 hours to 10 minutes. Yes, guys, 10 hours to 10 minutes. That would be pretty interesting. We'll discuss about it there. No scalability, guys. Most important feature that any data storage system must have is scalability. As we are aware, with time, our requirements change like anything. Requirements are getting requirements are getting actually increased. It's increasing day by day, month by month. Your storage system must be capable to scale itself to handle new requirements, new volumes. But you can't scale RDBMS. Single point of failure. At any point of time your machine is down, you need to wait unless that machine came up. Sequential processing, guys, you can't process your data in distributed manner there on a single machine. That means quite slow data processing. RDBMS can only handle structured data. Guys, recall what IBM told. More than 80% of the data generated today is unstructured. It can't handle these 80% of the data. It requires pre-processing of data, guys. According to data scientists, you must have your data stored in raw form. Raw form is the richest form of the data. But you can't store the raw data because, say for example, if you get the data in XML format or in unstructured format, you can't really store that as it is. You must have to pre-process that into structured format, then only you can store it. Apart from this, guys, there are tons of other issues. If you take any data processing system, whether that is a distributed system or any other systems, Like if you take the example of SAN, storage area network, there we need to move the data to the application machine from the storage systems. That is too costly. That is pretty much costly and a very big limitation. Now guys, let's proceed ahead. Let's talk about the technology that handles big data. The technology that handles big data, that is Hadoop. The technology that handles big data, Hadoop. Guys, what is Hadoop? The technology that empowers Yahoo, Facebook, Twitter, Walmart and others. Behind the success of all these big giants, the technology, that is Hadoop. So guys, what exactly is Hadoop? It's an open source project from Apache Software Foundation. It provides software framework for distributing and running applications on cluster of servers. Guys, important point here is the cluster. Hadoop work on cluster. It means multiple machines. Hadoop process your data parallelly, distributedly over multiple machines. Now guys, with the help of Hadoop, you can utilize the power of distributed processing. Parallelly, hundreds or thousands of machines are working for your job. So guys, actually Hadoop is inspired by Google. Guys, we are aware that Google today is the mother of all the inventions, all the innovations. Actually, Google has written a white paper over MapReduce as well as its file system, that is HDFS. And Duck Cutting and his team was working on Nudge search engine project at Apache. And guys, they got the similar requirements what Google has already developed. So guys, in this manner, actually Hadoop's development started merely as the sub project of Nudge. A small history, guys, we'll talk about the complete history later. But how exactly Hadoop was started? When a guy, Duck Cutting, was working at the Apache, he was having tons of issues to handle big data. And suddenly he saw a paper from Google and he started developing the same project as sub-project of Nudge. But guys, due to the popularity, soon Hadoop became the top level project. Hadoop came in the limelight when it defeated supercomputer. Guys, Hadoop defeated supercomputer in its early days in merely 2008 when it was not even in alpha. It defeated supercomputer in terasauts. And it caught the limelight. It came into the limelight, guys. And companies like Yahoo, Facebook, and big giants like Twitter, Walmart, they started investing in Hadoop. Even Cloudera, Walmart, IBM. So guys, in this manner the development started, and today we have a stable version of Hadoop that is deployed, that is actually running in almost all the big companies, as well as the small players are also running behind big data Hadoop. So guys, if we read few more definitions of Hadoop, it's an open source project, it's an open source framework that is written in Java. Open source means its source code is open. Let me highlight this word as well. Its source code is open. There is no need of any license. You can simply download and use, and even source code is also available. Now guys, you will ask me that Oh, it's open source. How industry will accept open source solution? As far as we know, industry won't accept any open source solution. So guys, answer to this question is Hadoop is the first project, first implementation that has been accepted by all the big players. Even Microsoft has done a partnership with Yahoo to make Hadoop compatible with Windows, as Hadoop was developed for Linux. So guys, today the scenario has completely changed. People are accepting open source solutions as well. Now still you will say, no boss, my company will not really go for open source. Don't worry, their proprietary versions are also available, like IBM, EMC, Cloudera. They are also selling Hadoop under their own banner. So guys, Hadoop is developed completely in Java. Now surely you, at this time, as soon as I take the name Java, you will be having a question. Java, it means to learn Hadoop. Should I have the knowledge of Java? Answer is yes as well as no. If you want to become a Hadoop developer, you must have Java knowledge. If you want to become an admin, there is no need of Java knowledge. If you want to become, say, a consultant, lead, architect, Java knowledge is not mandatory. For specific for a developer, Java knowledge is required. By the way, guys, you might have heard about that. You can even develop your code in other languages like C, C++, Perl, Python as well. But guys, since the underlying framework is developed in Java, it is recommended to code in Java. So for developers, Java knowledge is required. Rest of all, it's not mandatory. Hadoop efficiently process large volumes of data on a cluster. Guys, we already talked about cluster. On cluster, multiple machines. On cluster of commodity hardware. Commodity hardware means cheap machines, low-end machines, which we use for our day-to-day purpose, like Wi-Fi machines. Hadoop can be deployed in production on commodity hardware. Guys, it's really very big statement. I'm sure no technology, there is no technology in the world who will accept commodity hardware for production. Guys, due to its design principles, Hadoop can be deployed on commodity hardware. Due to its architecture, Hadoop can be deployed on commodity hardware. Guys, now you can imagine the very important factor, that's cost. Hadoop is pretty much economic. Guys, another reason behind the adaptability of Hadoop, another reason why everybody has accepted Hadoop as the solution. Guys, by the way, this is little old news, almost a year old. When I met with the director of Yahoo, Yahoo was running 54,000 machines just for Hadoop. 54,000 commodity machine just for Hadoop. That's really huge. By the way, guys, now you'll ask me that, oh, Hadoop works on multiple machines. They are like, I can deploy 100 machines. All 100 machines will work parallelly. But to learn Hadoop, do I need 100 machines? No. Guys, Hadoop can be set up on single machine for your learning, for your testing, for your R&D, for the development. You can proceed ahead with the single machine. But real power of Hadoop comes with a cluster. Surely, if you have 100 node cluster, you can imagine the speed, and even if you double the nodes, surely the speed will be doubled. So guys, by the way, we'll talk about it in next slide. Hadoop consists of three key parts. The first part, guys, the storage layer is HDFS, Hadoop Distributed File System. HDFS is the storage layer. Your data will be stored in HDFS. We'll be having a small intro of HDFS as well a little later. Let's proceed ahead to second component, that is MapReduce. Guys, MapReduce is the application layer, is the processing layer of Hadoop. And another layer is the yarn, that is resource management layer. Resource management layer. Since we will be having a cluster, so there must be someone who cares about all the resources of the cluster. So we have yarn. So guys, that's it about basic introduction to Hadoop. Let's proceed ahead to its architecture. Guys, this is how Hadoop looks like. A Hadoop cluster looks like. Let me highlight few things. So guys, Hadoop works in master and slave fashion. Surely it should be clear from the name. Master is just a coordinator which doesn't do work, which assign work to the slaves. Master assign work to the slaves. So guys, if user want to perform any work, he need to submit the work to the master. Now guys, what master will do? Master will divide the work into sub work and submit it to all the slaves. So guys, suppose if we have a cluster where we have 100 nodes, suppose I'm having 100 slaves there. So guys, you can imagine 100th work will be done by each and every slave. 100th work will be done by each and every slave. Guys, our work would be 100 times faster than single machine. Guys, at this point of time, if we compare Hadoop with legacy system, your Oracle work on just one machine. If I draw it here, just work on one machine. So guys, you can compare one. Okay, let me give you one analogy. One person building complete home, you can imagine he will be needing years. And rather than that, if we have 100 persons, 100 people working building a home, how much fast it would be. So guys, Hadoop utilizes the power of distributed processing. Your work is done distributedly across multiple slaves. That's why Hadoop is lightning fast. I hope this particular architecture should be clear. Master is a coordinator and slaves are actual worker machines. We'll talk about this particular architecture, all the nodes, all the terms as well in later section. Let's proceed ahead. Guys, the first component of Hadoop is HDFS, that is the storage layer of Hadoop. Guys, let me tell you, HDFS even today itself is most reliable storage system on the planet. Most reliable storage system on the planet. It is anticipated that by 2016, world's more than 70% of the data will be in HDFS. That's huge. Planet's more than 70% of the data in HDFS. So guys, HDFS is a distributed file system. It's a distributed file system designed to run merely on commodity hardware. So guys, Hadoop's storage layer is merely a file system. Where, okay guys, since it is a file system, you can create directory. You can store your data inside that, like you create on your file system, local file system. So guys, In this manner, Hadoop can handle any type of data. You don't need to create any table, any schema before storing your data. Just create directory, store data. You have a video file, store it. If you have a document, store it. If you have images, any form of data, just create directory, store it. That's it. No need of any schema. Now guys, few properties of HDFS, pretty important. It is highly fault tolerant. It is highly fault tolerant, distributed, reliable, scalable file system for data storage. We'll talk about these terms later, but just one liner definition. Fault tolerant, guys, failure of nodes doesn't affect HDFS. Distributed, your data will be stored distributedly across multiple machines. Reliable, guys, your data is stored quite reliably in HDFS. There is no chances of data loss. Scalable, guys, you can scale your file system at any point of time without any downtime. Guys, very big characteristics actually HDFS is having. These are pretty critical. It is developed to handle huge volumes of data, guys. Natively at the time of development only, it is developed for the volumes. That is large file size in the range of GBs to TBs. Guys, if we talk about the storage mechanism, you will be surprised a little bit how exactly it stores the data. A file is split up into small blocks. A file is split up into blocks of size 128 MB and stored across multiple machines. Your one file will be stored across, say, hundreds of machines. Suppose you have a file of size 100 TB. That will be stored distributedly across all the machines of the cluster. It stores multiple copies of data on different nodes for fault tolerance, for reliability. Let me discuss these two points, that storage mechanism once again. So guys, we have a very large file. We have a very large file which we want to store inside Hadoop cluster. How this file will be stored inside HDFS? Look at it, guys. Firstly, the file will be divided into smaller pieces, smaller chunks. These chunks are called blocks. These chunks are called blocks. So guys, the default block size 128 MB. The default block size 128 MB. Now guys, these blocks, look at the animation. These blocks will be stored distributedly across multiple machine. Guys, block B1 stored on this particular slave, block B2 here, block B3 here, and so on. Here one file stored distributedly across hundreds of the machines. Now guys, at this point of time, there must be a question in your mind. At any point of time, suppose one machine is down. There are chances. In real world, there are definite chances of machine failure. So at any point of time, if this machine goes down, then what will happen? If this machine is down, if just out of my 100 TB data, one block is missing, it means complete data is unavailable. What will happen to my all remaining nodes? Will the complete cluster become unavailable, of no use? The complete file become unavailable or of no use? As discussed, guys, Hadoop is highly fault tolerant. Guys, Hadoop stores multiple copies of blocks. Look at it here. Hadoop stores multiple copies of blocks. Block B1 is available at two more location. Default replication is 3. Look at it. Block B1 is available here as well as it is available here. So if one machine is down, no issues. Block B1 will be accessed from another machine where the replica is available. Now guys, in this manner Hadoop is highly fault tolerant. Very new design, out of the box, developed from the scratch. Innovative. Now you will ask me, who will take care about the information about the slaves or blocks? Master. Master stores metadata, that is data about the data. So guys, that's a very basic introduction of HDFS. Later we'll discuss HDFS in great details, each and every aspect of HDFS, each and every terminology, each and every characteristics of HDFS. Now let's proceed ahead. The second component, MapReduce. Guys, MapReduce is the programming model. MapReduce is the programming model designed for processing large volumes of data. Guys, HDFS for the storage, MapReduce for the processing. MapReduce is developed for the processing of data. How MapReduce process the data? Guys, important point. In parallel, by dividing the work into set of independent tasks. Your work is divided and processed parallelly, independently. Actually guys, MapReduce is pretty important. It's the heart of Hadoop. MapReduce is the heart of Hadoop. It moves computation close to the data. I'll show you this particular definition with an animation as well. So guys, this programming paradigm allows for massive scalability across hundreds or thousands of servers in a Hadoop cluster. Let's discuss the same once again with an animation. Data flow in MapReduce. Guys, now we have a Hadoop cluster. Where we have our data already stored. Data is already available here. Now a user will come. Now the user want to process this data. So guys, user need to write a MapReduce job. User will develop MapReduce code. He will submit the code on the master. User will submit the code on the master. Now guys, look at the beauty. Master will copy the code and send to all the slaves. Master will send one copy on this particular slave. This particular copy will process block B1. Another copy on this particular slave. This will process block B2. One more copy on this particular slave. It will process block B3 and so on. In this manner guys, your data is processed distributedly, parallelly across multiple machines. Quite interesting. Again, out of the box solution. So guys, that's the basic of MapReduce, just introduction of MapReduce. So during the training, the complete MapReduce section, we will spend almost 20 hours in MapReduce. 20 hours, even more than 20 hours in MapReduce. So guys, that's it about HDFS and MapReduce. Yarn, we'll talk in yarn section. Let's proceed ahead to Hadoop ecosystem. Hadoop ecosystem, guys, the complete all the components that is available in ecosystem. The first component is HDFS. HDFS we already talked is the storage layer. HDFS is the storage layer. HDFS is the storage layer, MapReduce is the processing layer. In between of HDFS and MapReduce, guys, we have resource management layer, that is yarn, yet another resource negotiator. So guys, we already talked about these three things. Let's proceed ahead. Next component, guys, we have top level component. These two components are called top level components, that is Hive and Pig. Hive is for SQL lovers. You can submit merely SQL queries in Hive. Hive is a data warehouse on the top of Hadoop. Hive will convert these SQL queries into MapReduce. So guys, you will ask me, oh, we have another front available. Yes, we have another front available in Hadoop, that is for the analyst. We have Hive. Analyst should focus mostly on Hive, big data analyst. So he can merely submit SQL queries and generate the insights. Guys, for the script lovers, we have another front, that is Pig. In the Pig, guys, you can write merely scripts, that is Pig Latin script, and this script will be converted into MapReduce job automatically. So guys, for all the professionals, we have different fronts for them to specialize. For the ETL guys, we have Sqoop and Flume. Sqoop is for the collection of data, from RDBMS to Hadoop and vice versa. And Flume is a general purpose data collection system. From tons of different sources, you can collect the data using Flume. So guys, we have tons of components. Now we have a workflow manager. Oozie, used for the creation of end-to-end workflows. Apart from this, guys, we have a very different component, very important component in the family, that is Hbase. Hbase is the NoSQL database. Guys, Hbase is the NoSQL database. NoSQL database comes into the picture where your SQL databases can't answer your requirements, can't handle your requirements. Hbase can handle the data in the range of thousands of petabytes and still can give you the response in sub-seconds. So guys, we have dedicated sessions for all of these components, like a different session for Hive, different session for Pig, different for Sqoop. So we'll discuss each and every component in great details. So guys, that's it about Hadoop and its ecosystem. Now let's proceed ahead to big data use cases. Guys, how is big data actually used? I'm sure you must have this particular question in your mind. How actually is big data utilized? How exactly it is used? Let's start with credit card fraud detection. Guys, before I start, let me explain what exactly is the fraud. Just one example. Like guys, there are millions of people using credit cards. What exactly can be a fraud? Say for example, what exactly are the chances of fraud? How exactly credit card company will come to know? How banks will come to know? At 9 a.m. I am using the credit card from Mumbai. Just after 2 minutes, from same credit card there is a request from Chennai. Oh, something missing. There is some issue. This transaction must be stopped. Usually I do the transaction from India. Suddenly a request from US. That's in USD. That too high amount. Again, this transaction must be stopped. So guys, a US national bank which has a revenue of $10 billion is losing about 2% of its revenue, that is $20 million, due to fraudulent card transactions. So guys, the objective is to identify whether the requested transaction is fraudulent or not. Guys, to identify potential fraud is quite challenging. Why? Because time needed to complete the transaction is merely few seconds. Just hardly in 2 to 3 seconds your transaction is complete. So guys, we need a new technique. We need again a new solution. That is an out of the box solution. We need to process the data in real time, data in motion analytics. Guys, because for millions of users, there are millions of users. For each and every user, there is a different pattern. For me, the usage pattern is different. For you, it is different. If I am doing any deviation in my pattern, that is a exception. And as soon as an exception is raised, there should be some security measures, like especially one-time password or sudden security check call or something like that should be done. So guys, the issue here, the most important issue here is the velocity, because speed is pretty high and time to respond is pretty less. Let's proceed ahead to another interesting use case, that's sentiment analysis. What exactly is sentiment analysis? Identify the orientation of opinion in a piece of text. That text can be from blogs, user comments, review websites, community sites, social media sites, or anywhere. Sentiment analysis provides substance behind social data. Guys, today each and every customer facing industry is running behind sentiment analysis. Why? Because guys, it processes the language and understands consumer feelings. It understands consumer feelings and attitudes towards brand or topic in online conversation. Important point, guys. Suppose I am a telecom owner. How people think about me, whether they like my services or not, it's very important for me. Suppose I am a mobile company, say for example, from owner of Apple. If today I am launching iPhone, what people are thinking about iPhone? What people are thinking about iPads, iPods, all my different products? What people are thinking about me? In an online conversation, what exactly people say about me, that will create my brand value. If I am having most of the satisfied customers, say out of my 100 million customers, say 90%, more than 90% customers are satisfied, it means big brand value. People are liking my products. But if people are saying negative, you need to take the action immediately. So guys, sentiment analysis is very important because it tells you what your customers think about you. Guys, there is a second use case in sentiment analysis. One is that what we discussed, that what people think about you, what people write about you. We can come to know, we can collect the data from Twitter and we can generate the insights that okay, these many people are saying positive about me, these many people are saying negative. Another important use case, guys, this is what my personal experience when I visited a leading mobile phone maker. What issue they were facing, what they were saying, that today I am launching a new mobile phone today I am launching a new mobile phone. Whether people are liking my phone or not, I don't know. Whether this would be a success or a failure, I don't know. How I'll come to know about it? From these sales reports. Sales reports might take 4, 5, 6 months because I need reports across the globe. So guys, let me read the problem statement for you. If a company is launching a new product, using sentiment analysis, we can identify users' opinion about the same. Based on users' opinion, guys, products can be improved if required. It enables business to make early decisions rather than wait for sales reports. Now guys, if we come back to that particular use case, so what is the issue of my client was, they are saying that after 6 months I'll come to know the people are not liking this particular model. And by this 6 month of time, by this 3, 4, 5, 6 month of time, I might have created thousands or millions of pieces. I might have manufactured millions of pieces. This is a very big loss for me. Is there any mechanism to generate the insights little fast? So guys, the answer was sentiment analysis, what I gave to my client. Guys, using it, what we did, we collected the data. Say for example, today at 9 a.m. we launched the new model. From that time, we keep collecting the data from social media, Twitter, Facebook. We collected the data from user review websites, blogs. We collected the data from news sites and number of different sites from different geographical location, India, China, US, and number of different countries and number of different cities. And we keep generating the insights that at this point of time, how many people are saying negative, say down the line 1 hour, 10 hours, 1 day, 2 day, 1 week. So guys, within 2 to 3 days, the insights, the picture is pretty much clear that what people are saying. If 70% people are saying negative about your product, it means guys, there is something big issue. Something is missing. There is big issue. You need to immediately stop the production. 70% negative, immediately stop the production. If say 70% people are saying positive, it's a success. Good, going good. 90% people are saying positive, very big success. If say for example 60-70% people are saying positive, still 30 to 40% negative. From that also we can generate the insights. What people are not liking. Say some people are not liking a specific feature. Secondary camera is not that much good. Internal space is little less. So these type of actually insights we generated, and company launched, my client launched the next model with the upgraded version, upgraded specs. So guys, there are tons of use of sentiment analysis, a single project. Pretty interesting. By the way guys, usually we have this particular use case as our main project during our training as well. Let's proceed ahead. Okay guys, retail data processing, again a very big use case of my big data career. Application for leading retail client in India. Guys, my client was getting 100 GB of invoice data daily in XML format. Now what we need to do with this XML data? This XML invoice data need to be transformed into structured format. But it involves very complex validation, verification and business rules implementations. That is quite complex guys. The issue here was that legacy systems are incapable of processing the data. They were incapable of processing the data in optimum time period. So guys, what exactly they were using earlier? They in their conventional approach, they were using Perl to parse this data for validation, verification, business rule implementation. Guys, important point here is that they were needing 10 hours to process their data. 10 hours to process their data. So at early morning 3 a.m. they were getting the data, and they were needing 10 hours to generate the insights. That's huge. That's really very huge. Guys, the requirement what I got was to reduce this time. If big data can reduce this time, frankly speaking, the requirement I got was if I can reduce this to half, just to 5 hours. 50% reduction is really pretty big if we talk before big data era. So guys, we did some research and we developed our complete solution in big data. We write core MapReduce jobs. Guys, when we test our solution, results were amazing. We reduced the time from 10 hours to 10 minutes. Yes, that's really wow. That was really a very big achievement. Actually, guys, big data utilizes the power of parallel processing, distributed processing. In Perl, their design was highly sequential. One by one records were processing at a time. And here we processed the data parallelly, distributedly across multiple machines, and even in a single machine also we did parallel processing. That's why, guys, the result was amazing. We got quite big applause from our client, and we got multiple accounts open also. By the way, guys, this is really the exact beauty behind big data. This is the beauty big data. Let's proceed ahead. Guys, we have one more use case from Sears Holding. By the way, this particular use case is available on Google as well. Sears Holding using Hadoop to personalize their marketing and loyalty campaigns. So guys, Sears has 4,000 stores with millions of products and 100 million customers. Sears has collected over 2 petabytes of data so far. Now guys, look at the problem. Their legacy systems are incapable of analyzing large amounts of data to personalize marketing and loyalty campaigns. Guys, if we talk about the conventional approach used by Sears for analyzing their data, they were able to analyze just 10% of their customers' data for personalizing loyalty campaigns on mainframe. Guys, look at the technologies as well. Mainframe, Teradata, and SAS. Processing time to analyze this 10% of data was 6 weeks. That's really huge. Now guys, they shifted to big data. They shifted to Hadoop with 300 node commodity server. Now guys, look at the beauty. Time taken to process 100% data is now merely 1 week. 10% 6 weeks, 100% 1 week. Look at the beauty of big data. Interactive reports can be developed in 3 days instead of 6 to 12 weeks. They saved millions of dollars in mainframe and RDBMS cost and got 5,000% better performance. That's really huge, guys. Nobody can really imagine this much improvement, this much 5,000% better performance. They increased revenues through better analysis of customer data. Guys, this particular use case, this particular case study is available on Google. I recommend all of you to go through this study. So guys, that's exactly is the beauty of big data. Let's proceed ahead. Guys, there are tons of use cases for big data. Let me take it a little fastly. IT infrastructure optimization, the current infrastructure that you are using, whether you are really utilizing the complete infrastructure or not, you can really optimize it using big data. Advertising analysis, important. Let me take few minutes to explain this as well. Advertising analysis, guys, earlier advertisements were broadcast. Advertisements were merely broadcasting earlier, like a TV advertisement, same for all of you guys. But today, for each and every user, advertisement is different. Let's take the example of Google advertisement. Guys, suppose if we are searching for a mobile phone, in next few seconds, Google will start showing you the advertisement of mobile phones. If we are searching for laptop, in next few seconds, Google will give you the advertisements of laptops. Advertisements are highly content driven. Guys, advertisements today are highly content driven. For you, the advertisement is different. For me, the advertisement is different. Google is able to identify each and every user, each and every customer separately out of its billions of users. That's really pretty interesting. Predictive analysis. Guys, as discussed earlier, today industry is not interested in historical analysis. They are more interested in predictive analysis. It means what will happen. Predict the future. And guys, today we have, with the help of big data, we can actually predict with an accuracy of around 80%. That's really huge. Customer churn analysis, biggest issue of every customer facing industry. Why my customers are leaving me? Biggest worry. So guys, with the help of big data, you can process billions of customer complaints. You can collect the data from all the available sources, all the unconventional sources, I should say. That is from social media, from user review websites, consumer forum sites, and so on. And you can come to know why people are leaving you, what exactly they don't like, what exactly is the issue, and you can take the required action. Aadhaar project by Government of India. Guys, Aadhaar card that Government of India is issuing, there is a retina scan, there is a scan of your fingerprints. All these data is actually stored in big data. All this data is handled by big data. Weather forecasting. Okay, let me go a little fast. Weather forecasting, guys. Today we have these sensors that with the help of which we can generate weather related data, like satellites are sending volumes. Apart from that, tons of sensors generating huge data, and with the help of big data we can forecast weather quite correctly, quite accurately. Healthcare analysis, guys. Even in the healthcare also there is huge contribution from the big data. Tons of researches are currently going on, and even some of them are even in the production as well, to help for the better healthcare systems. So we'll be discussing a few use cases in healthcare as well a little later. Let's proceed ahead to natural resource exploration. Guys, again, quite important application, quite important use case of big data. Guys, all the enterprises doing the exploration are using big data to actually identify at which location, from which location they should start exploration. So guys, actually there are tons of use cases, even each and everywhere, at each and every place we can implement big data, the power of big data. Few other use cases we talk later. Let's proceed ahead. Important topic, important section, future and careers in big data and Hadoop. Guys, compound annual growth rate. So guys, by 2020 big data market will reach $50 billion mark. $50 billion mark. That's really huge. Big data is increasing at the compound annual growth rate of 58.2%, which is highest in the industry. So guys, if we talk about Hadoop software market by types, application software, package software, performance monitoring software, and so on. If we talk about services, consulting services, training services, outsourcing services, integration and deployment service, middleware service, and so on. If we talk about by hardware type, storage, server market, network and equipment, and so on. If we talk about guys end users, manufacturing, BFSI, retail, telecommunication, healthcare, government, media, trade, IT, and so on. Everybody is using big data. Let's proceed ahead. Guys, by the way, it's not at all a secret that big data is the biggest thing currently on the planet. All the Fortune 500 companies started working on big data. IDC forecast suggests that big data technology and service market will grow at 40% a year, which is 7 times the estimated growth rate of overall IT industry. Guys, again let me highlight one point, 7 times than overall IT and communication business. Another resource suggests that by 2016 more than 75% of the data on the planet will be residing in Hadoop. Again, quite big statement. Let's proceed ahead. Guys, CIO Insights, leading magazine. Big data is big time important in the enterprise. A whooping 80% companies say big data is important to their ongoing business operations, with 43% saying it is mission critical. Guys, due to the shortage of big data talent, currently industries suffering the issue of shortage of big data talent. It's really big, very big issue. Today, if you need say 100 guys of big data, 100 people who are really having the knowledge of big data, hardly you will get one guy. Let's proceed ahead. Google trends. Guys, Google know each and everything. I think trend is, this particular graph is saying each and everything clearly. Red and blue graph is for big data and Hadoop. Look at it, guys. It is going up and up continuously. It is exponentially even growing up. On the other hand, your ETL and data warehouse is going down with time. It is going down. So guys, even you can type the same on Google and you will come to know about the trend. So the graph itself is speaking all the things. Let's proceed ahead. Now guys, companies hiring or using Hadoop. By the way guys, this is an unending list. IT companies: Infosys, Accenture, IBM, TCS, Wipro, Cognizant, HCL, EMC, Dell. Analytics outsourcers: Mu, Sigma, Fractal, Absolute Data, Latent View, Genpact, WNS, Datamere, Platform. Retailers, Reliance, Walmart, Sears, Tesco, Carrefour, Target, and so on. Consultants, PwC, KPMG, Deloitte, McKinsey, Capgemini, CSC, and so on. Guys, everybody is using Hadoop. If we take few more names, finance domain, Citibank, SBI, HSBC, ICICI, JP Morgan, Barclays, MX, telecom domain, Airtel, Reliance, Vodafone, AT&T, Idea, TTSL, healthcare, Novartis, Dr. Reddy's, Ranbaxy, Cipla, e-commerce, Amazon, PayPal, Flipkart, Snapdeal, eBay, and so on. So guys, everybody, all the companies, if you take any name, I would say yes, they are using big data. So guys, there is a huge demand for big data and Hadoop in the market. There are tons of job roles are available in the market. If I highlight, guys, major 4 job roles, that is Hadoop architect, whose job is to design, manage, and provide end-to-end big data solution. Guys, skills required for them would be HDFS, MapReduce, Hive, Hbase, Pig, Oozie, Sqoop, Flume, Java, and so on. All the skills are required for Hadoop architect. Experience level would be 10 to 12 plus years. If we talk about Hadoop developers, guys, who develops application in MapReduce, major skills required for him is MapReduce, HDFS, Hive, and Java, and he must have basic knowledge of other technologies like Hbase, Pig, Oozie, Sqoop, Flume, and so on. Experience level would be between 0 to 5 years. Similarly, for Hadoop admin, who manages, who monitors, who deploys, install, configure Hadoop cluster. The major skills required is Hadoop, Linux, network management, and so on. And guys, he must have basic knowledge of Hive, Hbase, and other ecosystem components. Experience is somewhere 0 to 5 years. Job role, next job role, Hadoop analyst, who analyzes the data, and brings out the insights. So guys, he merely runs SQL queries over Hive and bring the insights. Skills required, Hive SQL mainly, and basics of other components. Experience level is again 0 to 5 years. Apart from this, guys, there are tons of other job roles like tech lead, solution architect, pre-sales, sales, VPs, CTOs. So guys, at each and every level from 0 to 25 years of experience, tons of different job roles are available. Let's proceed ahead, guys. One more slide. A job trend which itself will tell you the complete story. Guys, look at it, how fastly the market is growing. Hadoop job market is growing up and up. It's almost exponentially up. So guys, the demand in the market is really huge and quite less talent is available in the industry. So it's a big opportunity for all the guys to grab it and start the career in the big data, the exciting world of big data. So guys, just little bit things about us. Why choose Dataflare? So guys, we have trainers who have more than 16 years of professional experience and more than 5 years of training experience. The training would be very interactive through GoToMeeting. You will be having the feel of classroom. You will be having the complete environment of classroom while you can be at home. You can attend the training from any location, from any device. Guys, another important point, there will be individual attention to all the candidates as there is an upper cap of 10 students in a batch. I have seen people are taking 25 to 30 guys also in a batch, and that is really very hard to manage. There would be like just one-way communication, and in our trainings it would be two-way communication. More practical sessions than theoretical, guys. Theory anybody can read from the books. All the instructors are pretty senior guys who are working in the industry. They share their practical experience with you that you can add in your resume, in your profile as well. Guys, another interesting thing, we will record all the sessions and we will provide you lifetime access of all the recorded sessions, all the study materials, all the code, PPTs, installation manuals. The complete study material will also be available in the LMS for the lifetime. We will assist you in the resume and interview. You can get a job assistance, guys. We have a job portal where we have our consultancies from where we get the updates of the jobs available in the market, and that particular portal is updated regularly. You can get the access of the same. Regular study material, assignments and workshops for better learning, guys. In each and every session, we used to keep giving you tons of assignments, tons of practicals, workshops, which enhance your learnings. We also have POCs and a live project during our course. Again, to make you expert, guys. Even we will go to the level of customization. A certain component, if it is not fulfilling your requirement, we will customize it. We will be having discussions to that level. On completion of course, guys, you will be provided training certificate from Cloud Data Flare, and this course will also prepare you for Cloudera certification, the leading certification in the industry. What is the end result of doing this course? You will become employable in big data and Hadoop industry. Very big statement, guys, I am currently giving you. You gain the practical skills which employer needs rather than theoretical knowledge. You will be working on POCs, live project that you can update in your CVs. And guys, let's discuss, you can get the job assistance. Thank you so much, guys, for attending this session.